I bet you don't know that there are different kinds of numbers. Well, there are. There are different kinds of numbers just like there are different kinds of dogs. Like German Shepherd, Poodle, Bulldog, or Chihuahua. They're all different, but they're the same enough to all be dogs. Same thing with numbers. So today, we will discuss about the types of numbers in the real number system.
Real numbers are elements formed from the union of the set of rational numbers and irrational numbers. What are rational numbers? A rational number is a number that can be expressed as a fraction or ratio in the form a over b, where a and b are integers and b is not zero. Examples: 1/2, 8, 5 over 3, square root of 4, 7 and 1/2, -12, 6.25, 0.311. When a rational number fraction is divided to form a decimal value, it becomes a terminating or a repeating decimal. Examples: 1 over 8 becomes 0.125, while 1 over 7 becomes 0.142857142857142857142. As you can see, there's a pattern. Some rational fractions may produce a large number of digits in their repeating patterns, which may exceed the size of the viewing screen on a calculator. The fraction 53 over 83 has a calculator display of 0.63855,42169, which shows no repeating pattern, when in reality, the pattern will repeat after 41 digits. Subsets of rational numbers. There are three subsets of rational numbers. First are the integers. The counting numbers and their opposites and zero are integers. For example, from negative infinity to -3, -2, -1, 0, 1, 2, 3 to positive infinity. Next will be the whole numbers. Zero and the positive integers are the whole numbers. Example, start with 0, next will be 1, 2, 3 to positive infinity. Next will be the natural numbers, also called the counting numbers. This set includes all of the whole numbers except 0. Example, 1, 2, 3 to positive infinity. The next set will be about the irrational numbers. What are irrational numbers? Any real number that cannot be written in fraction form is an irrational number. These numbers includes the non-terminating and non-repeating decimals. Irrational numbers are also called the ugly numbers. Any square root that is not a perfect root is an irrational number. Examples: square root of 2, square root of 3, the number e or the Euler's number, square root of 99, square root of 5, and 5.91607977831, and many more. What about pi? Your previous math classes have instructed you to use 3.14 or 22 over 7 to represent pi. These are only approximations or estimates. They do not change the fact that pi is an irrational number. As you can see, non-terminating, non-repeating.
Why not try some problems?
There you go.
Classifying the real numbers. Name the set or sets of numbers to what the number belongs to. When doing this, it is asking you to state all the groups that we had just talked about and say which group does this number belongs to. In number 1, we have 2/3. First thing, always real. Second thing, ask yourself, is it rational or irrational? Well, 2/3 is already expressed as a fraction, so it is rational. Since it's rational, you gotta keep going. The next question will be, is it an integer, a whole number, or a natural number? 2/3 is a decimal and it's a fraction, so it's not an integer, a whole number, or even a natural number. All these belong to the real system and rational numbers, and there's only two sets that 2/3 belong to. Now, we look at -16. This is a real number, and it can also be expressed as a fraction by writing -16/1. So, this fraction is rational. But first, it is real. Rational. It is an integer because it's a whole number and its opposite. -16 is the opposite of 16, so it is an integer. But since it is not a counting number, including 0, I cannot list it as a whole number or a natural number. So, it's just these three groups that 16 belongs to. Looking at number 3, 0. 0 is real, of course. It is also rational. It is an integer also because it is a number, its opposite, including 0. We also know that it's part of the whole numbers because it is in the counting numbers, including 0. And yes, it cannot be natural. In number 4, we have square root of 2. Remember, we gotta figure out what's its square root. In the calculator, it is 1.4142 and so on. And it kept going. It never repeats, so we don't know that it's real. But this time, it can't be expressed as a fraction, so it is irrational. Since it's irrational, it cannot be something else. Looking at the number 5, which is square root of 25, we know that square root of 25 is 5. In order to figure out what square root of 25 belongs to, I've gotta think what 5 belongs to. We know that it's real. It can be expressed as a fraction, so it is rational. It is also an integer. And it's part of the whole numbers. Is it a counting number? Well, yes. Then it is also natural. Now, the last one is 3.14. Well, everybody will say that it's a pi. I know that because that's what we normally use to represent pi. But this is not a pi. This is pi rounded. But 3.14 is just a number, so it is real. We can put it into a fraction, 3 and 14 over 100. So it's real and it's rational. But notice, since it's in decimal, it can't be an integer, a whole, or a natural number. So it's only real and rational. I hope you learned something. Next week, we will have the properties of real numbers.